Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, everyone. Welcome back to another exciting edition of IT Pro TV. I'm your host, Vaughn Smith, and this is our Cisco Cloud Fundamentals series. And right now, we're going to talk about file storage access. And here is the Mr. Ronnie Wong. How are you?
I'm doing well, Vaughn. Thank you again for joining me as we continue on in our kind of little series here, right, on cloud storage and, of course, the Cisco Cloud Fundamental series itself. We are trucking along pretty good. We are in our final domain objective, Vaughn, which means we're pretty close to the end. And briefly, right, in the past couple of episodes, if you've been watching in sequence, what you've actually seen is us go over the idea of block storage access and technologies that are normally associated there. When it comes down to, well, at least for cloud providers, right, and getting access to that, block storage itself is probably the main one that we'll focus in on, but it doesn't mean that file storage access itself is any less, okay, important, because file storage access is how you and I tend to interact with that cloud environment as users, okay, is what we have. So when we come down and we start talking about the idea of file storage access, well, for us, we've got to remember the big difference here, right? Remember the idea of block storage really gives us access to the capacity that we normally would need if we're actually going to, well, use our service, right? So when we access it from a regular computer, block storage looks like hard drives, okay? And that's what it is. So let me show you an example of what I'm talking about here. So on my screen, I've gone ahead and I've brought up a Windows 10 computer is what I've done. And I know it's a little bit small, but I'll zoom in when we have the chance to so that we can see it. I'm just going to bring up Disk Manager here for just a moment, or at least I think I am. If I can remember how to use a Windows machine. It's been such a long time, Vaughn, that I have to actually bring this up, okay? So, Vaughn, when we take a look at the idea of Disk Manager, just as an example, right? Notice that what you see here, Vaughn, are not individual files, but you see access to, oh, look, a disk, right? In Windows, we, of course, call this our root or C, okay? And then you have different partitions that you can have access to. But overall, though, that's what you see here, okay? So notice, Vaughn, that even though I'm accessing this, it's not really individual files. I'm not going in. I'm really just accessing the space. And that's what block storage access gives us that ability to do. When I need to access files, though, I can simply launch up my File Explorer itself. And in File Explorer, Vaughn, this is where I can get access directly to, well, files is what we can actually see and do, okay? So here's where we can actually, kind of be able to now gain access to individual files that we can use and be able to see a couple of other things as we've been working on them as well. So oops.
Do you have two downloads folders, or is those
I
just
do.
shortcuts?
Yeah.
They're just
Actually,
two shortcuts
yeah,
to
they're
the
two
same
shortcuts,
download. I'm
yeah.
like, you're not supposed to have multiple download folders.
Yeah, no, they're just two different shortcuts.
Just double checking on that.
Yeah, that's fine. Yeah. So you have that. And so that's actually important for us. And so if I want to see, this is how it actually ends up looking. So when we talk about block storage, we're accessing the capacity of the drive. Talk about files, we're inside with a file system, and that's what we're doing. Now, Vaughn, the idea behind file storage is really to make sure that we get access to those files wherever they're located on the hard drive itself. And that's key for us as we get started here, okay? And the reason why is that we have to actually begin with this idea of, well, how important is file access? It's very important because if we just store individual bits is what we're actually doing, right? They have to be able to be associated together to make sense of data for you and me. So, Vaughn, I just finished reviewing, a couple of different documents for something we're going to be publishing in the near future here, or at least. So I was trying to make sure that I went through it and I read it and that I did everything that I needed to. Well, Vaughn, when that gets stored onto a computer's hard drive, it's not stored like what I think, which is taking a piece of paper, putting it into a folder, putting it into a file somewhere, right? A file cabinet. I was trying to remember the actual proper term. It's been so long since I've actually used one, Vaughn, that it's not literally doing that. What is it doing when I'm actually using a word process like Word to do something? Well, once I hit save, it stores it as what? Bits. Okay, it changes it and it stores it as individual bits on the computer itself. But what it does is it says, hey, we're going to store this together. So even though they're actually turned into bits, we're actually saying all that information belongs together so that when you retrieve it then, it knows that it's tagged with that information, what we call metadata, to pull that information together and go, it's going to be presented as a single file. Okay. So the idea of actually understanding that is the key, is that file storage really does that for us. Okay. And the way that we access that is also key, is how do we actually do that?
Wasn't there something, a disk defragger?
Mhm.
Like when you defrag your hard drive, it's supposed to take all the places where the information is written and try to put them closer together
Right.
or in different partitions, if you want to
Yeah.
say.
And the way that that worked is that it used file names and the metadata that was attached to the way that files could get fragmented on your hard drive to pull them all together so that they were actually easily accessible, is what we did. So now this is the same thing that we have to actually think about. The way that that ends up working, Vaughn, is through what we call the idea of namespacing. Okay. Namespaces allow us to attach names to individual files. Okay. And we have to be able to understand that by us not having to try and figure out, Vaughn, in this sector of this, of the hard drive, here's this stuff. You and I, we just have to memorize what a name is going to be, and that's the key. So these particular namespaces, though, they're really tied to operating systems a lot of times. So, for example, Linux and Unix would have a different namespace, or the way that they actually name files as well, a little bit differently than something like Windows would actually do. So there's some limitations that won't cross over, that won't allow us to do that. But, Vaughn, just as I say that today, though, there is different technology that allows us to be able to run both of them even on the same machine in terms of the file structure and the namespace as well. Okay. So, for example, if you take the idea of Linux, right, there are rules to the way that you can name certain things. There's special characters. We're not going to get into all that, but just kind of realizing there'll be a review for you if you haven't done this in the show notes as you go through. If you're an IT Pro TV subscriber, you'll get access to that. But names essentially can be up to about 255 characters, but there are special characters that you can't use in the names. Okay, so that's kind of a rule that we have. Okay, you also can't begin a single file with something like a dash. Okay, and in Linux and Unix, file names are actually case sensitive. So Vaughn, if I actually name a file after you and I call it Vaughn Smith, okay, and it's a text file, well, if I actually type in a capital V and a capital S, that's different than another file if I actually left it all lowercase. Okay, so that actually turns out to be two separate files, even though you and I might think it's the same file.
Right. This reminds me of back in the day when I would teach like basic HTML. We would say that there's naming rules for naming your HTML files: no spaces, no special characters, and lowercase.
Right.
Because a lot of your web servers would be Linux or Unix based, and so you just want to make sure that you conform to naming your files correctly.
Right, because if you don't, when it tries to pull it up, it's going to say, yeah, I don't know what that is, and you now point to a file that doesn't exist. So Linux and Unix, those are great, operating systems that are out there, but you do have to follow the rules for them if you're going to create something like that, okay? In Windows, now, this is something a little bit different as well. Just inside of Linux, right, because you can have up to 255 characters, actually there's a limitation of 8-bit binary numbering, right? Well, in Windows, though, you can actually go up to 260 characters for a name. Now, the name, when I talk about it, I always think about just a file name, right? So just like I said vaughnsmith.pdf or .txt. But Vaughn, the actual name, for us to be able to find it and be able to actually locate it where it actually goes, it actually includes what we call a path name, or, that's the key. Let me show you an example of what I'm talking about here. So let me go back to my machine, and we'll bring up the File Explorer again. We'll take a look at something like, let me do something else that's local. Let me see if I can find something that's local here. I don't know if I can or not. Let me go to this computer. I will do documents. That'll actually work. Okay. So documents, Vaughn. So I have here a bunch of different documents. Okay. Some of these were actually from a previous show that I did, which is perfectly fine. But Vaughn, here it is. I have a file here in a Cisco Enterprise Architecture Model.vsdx. Okay. That's perfectly fine for us and what we actually want to be able to do. But if I take a look at it, the name is not only here, but if I come up here and I click on this, maybe I shouldn't.
Ronnie, I know you used to be able to click up in there and it would show you, but can't you also get in there by right-clicking on the file and then going to the properties? That always gives you more information.
That's actually a great idea. Let's go ahead and try that and see what happens, right? So there it is. I tried to do what it used to actually just show up here, but now I can right-click on this. If I go down to properties like what Vaughn's saying, right here in the property sheet, You can see, oh, there it is. Okay, you can see where it says location if I can highlight that. And that's what we're looking at right there. Okay, so that is the path name that we're actually doing. We take that, we append the name of the file to the end, and that gives us what we're wanting.
And a lot of people, it's like, oh no, it's just your documents, but there's actually a lot more in front of it,
Right.
like your users and what's the name of the user you're located in, and
Right.
it's stuff that normal end users don't think about or see that much, but there is more in the front of it.
Yeah, talking about the idea of that, right? So this is what we call metadata, essentially, is what you call it. So everything actually in this file includes these properties that we're talking about. Includes that, all this information that you see here, including groups that we talk about as well, and what groups, users, and permissions, which we'll get into a little bit later. Any other additional details that we want, you name it, it all actually is attached to that, and every single file has this, okay? So that is where you actually can find a lot more, and how the operating system begins to use that for us, okay, is what we begin to see here, okay? So Vaughn, the idea of actually having that name and understanding the purpose of namespace is good, okay? But it also is different, right? Between the Linux and the Windows systems that are out there, you have that. But all that is also, of course, part of the very fact that different operating systems use different file systems as well. File systems are essentially like the filing system in an office, okay? You might go to a doctor's office and they might file things one way. You might go to a dentist's office and they file things a little bit differently. You might go to just a regular business office, right, where they do other things and they file things differently. Well, operating systems tend to actually make their files formatted the way that it's actually easier for those operating systems to work and to do what they need to do. And of course, Linux and Windows, Linux, Unix, and Windows essentially have, different file systems, and we want to make sure that we at least know the names of a few.
It's kind of like in filing systems, you can buy the manila folders that are like the letter size, or you could do like the longer ones that are the 14-inch, the tabloid size,
Yep.
Or legal size.
Right.
And they fit differently.
Yeah.
So it's either here or here. It's still storing your paper documents, but they're formatted differently.
Yeah, and going to the idea of the file system is about the filing cabinet itself. If we use that analogy, right? The legal size ones aren't going to actually fit into the ones that are regular standard size, filing cabinets as well. So when we talk about a filing system, it's actually making sure that we got the right file cabinet for the size files that we need and everything else that we have to do. So in file systems, for end users at least, for what you and I tend to think about, we have to at least discover a little bit more here. Okay. So for example, if we actually go to Linux, okay, and Unix here, the file system that they call out specifically here is going to be what we call the extended file system, or EXT. And there are three different varieties of EXT: 2, 3, and 4. Those are the different versions. And this really has to do, the very fact that there's different versions means that technology, again, has updated itself too over time. So EXT2, good at things like removal, storage types of things, removable media, but you can have an individual file size of up to 2 terabytes, which is huge. Okay, 2 terabytes is gigantic here for an individual single file, but the hard drive limit is about 32 terabytes in terms of the maximum size. You also have the ability to have compression. Go to EXT3, you still have a 2 terabyte file size, but you're no longer talking about being able to put it on to removable drives anymore. You're actually going to regular standard hard drives at this point. And then again, still a 32 terabyte limit, but the latest one that's out there, EXT4, still again on regular hard drives, but this time a single file that can be actually sized is 16 terabytes. I don't even know how in the world or what in the world would actually be a 16 terabyte file. The only thing I can even think about at this point, Vaughn, would be something like a virtual machine file. That's the only one that I can even think about. And usually those are multiple files that are stored inside of a single one too. But you also have a maximum volume size of about 1 exabyte. Okay, exabyte is huge because if you actually know, like it goes tera, peta, and then exabyte. Okay, so that means it's actually 1,000 terabytes. Okay, so go figure. Yeah, so 1,000 times 1,000, or 1,000 petabytes, which is actually, that's huge. That's what, 1,000,000 terabytes.
That's a lot.
That's a lot.
That's a lot.
Yeah. So a single volume being that size is pretty hefty. Okay. Now, there are some features that came along with it. We're not so worried about all the features that are actually available there, but just kind of realize it's there. Okay. In Windows, though, there's FAT, okay, which stands for File Allocation Table. As much as I'd like for it to stand for FAT, that's what it stands for, File Allocation Table, and how you're actually able to name stuff. And these have been around for a long time. So Cisco doesn't they actually kind of expanded this out a little bit more than what I would have. They call out FAT12, FAT16, and FAT32. Most of us just called out FAT and FAT32 is how most of us would have remembered it here. Okay, same thing. There are limitations to each one of these types of systems, right? So the big limitation, at least when it comes down to Windows, is a file size. Okay, so the earliest ones had a maximum file size of about 2 gigabytes. Okay, but if you went to the 64-bit operating system, then you had 4 gigabytes that a single file could be, and then the volume size in the earliest editions of FAT12, FAT16, 2 gigabyte maximum size there. When you go to FAT32, which is kind of the latest one, they had 4 gigabytes in size and then a 2 terabyte hard drive. Not so important we remember all the details, but between EXT and FAT, those two are kind of the key ones, at least that we would have remembered earlier on. Okay. Now, the one that Windows says you should absolutely run unless you have a good reason not to is what we call NTFS. NTFS essentially is a file system on steroids, okay, is what it really is. And the reason why I say it's a file system on steroids is it includes things that the other file systems have to a point, okay? It includes things like file permissions. Well, in Linux and Unix, we can have read, write, and execute, as file access. Well, in Windows, you have a ton of different permissions that are available. Read, write, read, execute, list, folder, content, modify, full control. There's a ton of permissions that are there. But it also includes a journaling file system as well. EXT also does that too. Compression, encryption, you can do that too. You can do what I call volume shadow storage, which includes versioning, is what it allows you to also be able to do for your individual files, and disk quotas. So Vaughn, all that is not built into individual files or an application. It's built into the file system itself, which is why Windows recommends that you actually use this if you have a chance to do so. Okay, so Vaughn, all that really wasn't so much. It's more of a review than anything, but don't put it past them on the exam to just see, do you actually understand anything about file systems? But the ones that we're really wanting to at least talk about briefly, okay, is the idea of what we call remote access file systems. And this is when we talk about the two major ones here. And we're just going to mention the name of them because we don't really get into all the details behind them. As you actually start studying more about NASs and SANs and stuff like that on your own into the data center, you'll actually get into those a little bit more. But here, you begin to talk about NFS. Now, I think that there's a popular video game that's actually abbreviated this, Need for Speed. Ever hear about it? Yeah, that apparently is what NFS comes up with for most people when you actually do this. It's like Need for Speed. I always knew it as NFS, which is Network File System. Okay, but that one tends to actually come up every once in a while. NFS is a IEEE standard, and it's been around for a long time. Linux and of course Unix, operating systems like to use this, and it's all based around standards. Okay, it pretty much is what it does. It allows us to use IP to establish all of our sessions between clients and servers, and it can actually use UDP or TCP to do whatever else it needs to. Now, there are a couple of different things that you want to make sure that, as you think about it, right? If you're using Linux and Unix computers, more than likely, if you're getting access to files, you're probably using NFS. Okay. What about in the Windows world? When the Windows world has SMB, server messaging block. And of course, even the older standard is that we call CIFS, which is a common, common internet for file system, I think is what it stands for. CIFS. Okay. So I think it's Common Internet File System, if I remember right, is what that one stands for.
You are correct.
Yeah. So sometimes you just use the acronym so much you forget what the actual names are. I was like, Internet? Yeah, it's Internet File System is the one that you see there. Now, both of those are compatible, of course, for Windows computers, okay, as well. So making sure you can identify that and understand what type of system that you're using is key, okay? Now, once you actually have that established, it's not that everything just happens automatically, okay? Every user that actually accesses the remote file system, they have to initiate a connection to that device And then that device actually allows you to gain access in to whatever that system is going to be. NASs are probably the most popular access type of system because they're easier to do so. And implementing a file system on top of them is actually relatively easy, just like the regular desktop computer. It doesn't take much to be able to do so and doesn't take a lot of setup to do. Unlike something like the block storage access, which takes a pretty hefty amount of configuration to get it all right. But Vaughn, once we get the idea of the file system set up, then we can begin to use different protocols that are out there to help us to make connections to files. FTP, right, the file transport server, that's actually been out there for a long time. Gives us the ability to access and to copy and to move files, but pretty much unencrypted. Okay. There's also TFTP. Now, most of us probably don't use the trivial FTP server, but that is actually FTP done over UDP. And where I tend to use it more often is when I'm trying to upgrade a Cisco iOS device, is what I'm doing, where I'm actually copying the config off of a Cisco device is where I tend to see that. But if you're doing this across multiple networks or somebody else's network, you want to make sure you do a secure copy of it. So there is SCP, which of course is Secure Copy Protocol, that allows you to ensure that you're using port 22 SSH to be able to copy all the files over. Sometimes, of course, they even set it up to make it easier. Today, Vaughn, the realm of networking devices and having internal web pages is pretty much key. So you might even see HTTP and HTTPS actually turned on as well. So I can do that. I can actually set it up to where I just want to get access to make it easier for somebody to be able to use what they actually know how to do, which is essentially web surf, and do everything else too. And of course, if you're running Apple, there is AFP, which is the Apple File Protocol. Okay, that is also going to be part of some of these different protocols that you can access. So Vaughn, around here, because we do run a mix of Windows and Linux computers, we have centralized file shares, and they have to be able to access these different ones. So we have our own NAS, in which we do. We have Apple computers, just like what you and I are using. Others have Windows computers, and they have to be able to use some of these protocols to access and to change things the way that they need to. But all that is set up once you get the network file system up and running the way that you need to. It actually makes it very easy then for end users to be able to access this very hefty network storage device, but to be able to just retrieve what they need. They're not going to go in there and actually change out the entire structure of the volume that they're doing. In other words, they're not adding in a new volume as what they're not doing. But what are they normally doing? They're accessing files. And you can even make it to where I could prevent Vaughn from accessing it, but I could actually access it perfectly fine myself from anywhere on the network if I wanted to as well. So these file systems are actually very impressive in what they actually do. They give us access, or they give end users the access that they need towards what they're normally working with on a daily basis. All right, Vaughn, so that pretty much ends our kind of brief review here of file systems or the file storage access. So this is not a hefty review at all, right? It's something that you should be familiar with and be able to kind of go, all right, that actually sounds good. I don't really have to worry about it. Well, that's great. But just kind of realize it's all a part of something that you might be able to see on the exam. So we want to make sure that we covered it here too. All right, so Vaughn, once we actually done with that, that means we're ready to move on to another topic. So we'll end this right here.
All right, well, that sounds great, Ronnie. Great review of our different file storage systems and all that good stuff. But we're going to go ahead and sign off for IT Pro TV. I've been your host, Vaughn Smith.
And I'm Ronnie Wong.
We'll see you soon.
Thank you for watching IT Pro TV.